This is chapter 8, and writing today is Diego. So I will let him share his screen share with the rest of us.
All right. I hear some noises. Make sure nothing coming out. Can you hear me?
I can.
Okay. All right. So pretty much this chapter starts where the acquiring behavior through inheritance ends. And in that one, we had we finished having like a road bike, the inheritance from bicycle, mountain bike, the inheritance from bicycle, for determining how many spares, what kind of spares they have. But what if you have for example, a recumbent bike? You will a recumbent, like laying back, right?
Those are cool.
Bicycle, easy to do, right? But what if now you have a mix, like a recumbent bike, mountain bike, recumbent mountain bike?
Doesn't that sound dangerous?
Oh, yeah, they exist. So maybe in that case, because it's two different child of bicycle, you cannot just blend them easily. It would be something hard to do, and that's where composition kind of comes in. So composition, so inheritance is kind of like you do it when you have the relationship that you have between the different objects is a type of this. And sometimes, like if you know your code is not changed, even if it's like a has a, you might still get away with the inheritance, but we'll go on why composition is better. But it's all a little bit of middle taste, a little bit of, I don't know how well the code is going to change and that kind of stuff. So they're going to update the bicycle class from just being a bicycle with many subclasses to have a bicycle that has a parts collection. Mm-hmm. So when you can ask the bicycle for the spares, and the bicycle is going to ask a class called parts for the collection of spares. So like in the illustration, this is the interaction diagram, and the diamond says it's a composition. So a bicycle is composed with exactly one parts. Mm-hmm. So it has a part. And it is fair enough to implement. Mm-hmm. You inject a parts object when you instantiate the bicycle. And over here, it's a second parameter. Well, the arc parts is set to parts, and then you can ask spares to bicycle for each spares. Now let's look at the parts class. So the parts class is going to have chain, tire size arguments, like you had before you were getting those from the bicycle itself. Mm-hmm. When we were doing an inheritance. And he's got spares, so you go merge the local spares, tire size, the chain, which is like from here, right? Tire size again instantiated there, and then we can see it grabs the chain or uses the default tire size or the default tire size if it's not provided, and then run some post-initialization, which returns nothing here. But like some of those defaults raise errors because like you don't have anything defined. And well, in this refactoring, pretty much is like all the inheritance that was on the bicycle is now moved into the parts. So now we got like a base class called parts, and then we have a road bike parts, right? A mountain bike part with their own post-initialization. They might have a tape color, different tire size, different measurement, all that kind of stuff. So, and it says the code is nearly exactly of the bicycle hierarchy. The difference is now we remove, we can rename and move them as subclasses of parts. Something that has happened in this is now bicycle is actually very, very simple.
Yeah.
Like it's almost like a shell. We can start reasoning. It's fairly transparent with what's happening here. So when we want to do a road bike, we just do bicycle new, the size. We're gonna do, and for the parts, we're gonna have a road bike parts with some post-initialization parameters, and then we can still call size on the road bike. We can call it spares, and we see it returns a hash of values,
yeah.
right? Same thing for the mountain bike. We got that. We got size and spares. And again, like in here is like the observation for me was like just how little specific code to bicycle there was in the beginning. It was mostly about determining the spares. All right. So the parts, because we call this a parts. It's a collection of parts, or part, right?
A single part.
A single part. It goes in a little bit of a conversation about any convention. Now, parts, it's obvious there's a collection of single part. So if we were to make like these thing that now hashes objects, now we have a part and parts classes, and for as long as you realize there are two different classes, one, and then whenever you say parts, you are not talking about an array of parts, but the parts object.
Yes.
There's a collection of parts. Then you're good. If there were better naming, you would try to keep those two separate things. But like this is fairly self-explanatory and sounds right. Instead of creating like a class called part collection, you can say parts. So now we have like an interaction as change a little bit. So bicycle calls spares to parts. Now parts goes through all the part that it has and asks each part if the part has a spare or not. So now whether the like who knows whether you need a part or whether you need a spare or not is not a job of the bicycle itself anymore. It's a job of the part. So we are moving the one job down the line, down the chain. And again, we can see with the diamond, black diamond, bicycle has one part, and part has one or more part. And that's what the one that range means. So we're gonna go and we start creating the part. So let's look at the code. The bicycle is a shell right now, just have size and parts, and the method spares, right? The parts also is cleared up quite a bit.
Yeah.
Now it's a much smaller class than before. Before we had all kind of subclasses, defaults, and all kind of stuff. All that is gone. So now we have parts as a parts reader, so we can call it like that, and we don't create a dependency on the instance variable. We assign the parts in here, and then we loop through them, and we ask each part whether we need a spare or not, and we select only those. Again, part right now has only these three things, and again, part is also become a very small class, very simple, and we might have gotten like to the same level of simplicity through the single inheritance, but it would have been all in one thing.
Yeah.
Right. So like the single responsibility now is very clear. Like who knows whether you need a part or not is the part object.
Yes.
And before it was like, oh, I need to do a whole bunch of calculation or whatever, right? Or it was maybe hard-coded to the subclass. Mm-hmm. Now, you can instantiate a bunch of different part object, right? Assign all those parts to a parts collection, right? You say a road bike has this type of part. And a bicycle, with that, all those things, we can still call size and spares. Now the difference here is we get, when we call spares, we don't get a hash anymore, but we get a collection of part, like an array specifically. Right? Mm-hmm. Yes. Let me make sure. Yeah, because this is select. It returns a new array. It doesn't return a parts collection or part. It returns an array of part objects. All right. Even talking about it, like I said, I have to make sure that I don't say parts, but part objects. Mm-hmm. That's kind of like a bit we discussed before.
Yeah,
in the naming convention.
Kind of works with the part objects.
Yeah. All right. So there was like a road bike, mountain bike, similar things. We have already created all the possible part objects. And now it's still the same bicycle class with nothing different. Still the same part with nothing different. Now, the only difference is the stuff we pass to it. Yeah. And size and spares still return the correct stuff because it's just looped through them. Something it talks about this is whenever you have a composition, the object that, and I'm having a hard time, okay, whenever you have a composition, the object that is you're composed of as a thing, mm-hmm. you should not get too hung up on that thing, what that thing is. Meaning, right? So right now, part is a the class part. But the class part doesn't have to be a class part, as we're going to see in a second. It's something that plays the role of a part. This is, again, dynamic language. You can swap with whatever you want. So what is like in the UML diagram doesn't necessarily need to be a class. It's not a one-to-one ratio all the time. And before it goes into that, it says, well, you know, I assign parts, right?
What do you expect from parts?
Right. What do you assign from parts? So when I create this mountain bike, I assign a bunch of parts to a variable parts, and I can say mountain bike does spares, and it brings me all the spares, all the things that have a spare, right? Or they need a spare. But if I want to know all the parts, how many parts there are, and I'll call parts of the size, I don't get the list. And the reason why is the parts class is not an array.
Right.
But it kind of behaves like an array.
Exactly.
And this is kind of like whenever you create a class that behaves like an array, or like a hash, or like something else, you might start thinking it is an array, it is a hash. So you will treat them as one. And then when you do, you're going to end up with surprises.
Yep.
Sometimes happy, sometimes not. Most likely not. So one you say like, oh, the WS fix here is to add the size to parts class. That does parts that size. Cool. You know that can work, but what if I do parts that each? That's not gonna work.
Right.
So do we want to implement all of these methods?
Yeah.
One solution is to have parts inherited from array.
Right.
Right? So parts inherited from an array. While this might work, there are a lot of methods in array, and they bring up here the plus. But like before, I even mentioned select. They return not a new instance of self, but a new instance of array. So even if you have an object that inherits from array, you do, like here, that's like includes the plus sign. You know, this array-like object plus this other array object, it combines all the children correctly.
Okay.
But the new object that you got back is not a parts.
It's an array.
It's an array. So now you're gonna start asking spares this new object, and it's gonna bomb. So that is like a problem with generally inheriting from arrays, from hash, and like stuff like that.
You might have to define all the array methods so that instead of returning
everything else,
as a part,
yeah, that returns an actual array. But you need to learn which one those are, right?
Yeah, exactly.
You need to look, oh, this returns a new array, this returns a new array. Sometimes it isn't enough, you know, but like array has a lot of methods. Yeah. Hash has a lot of methods. And actually, like my favorite solutions here is to use enumerable. And again, this is like all a balance. Yeah, I always do a balance. You need to know kind of like who's going to touch the code, what people are going to do to this code, You might actually just say, adding the size to parts is enough. And if anybody wants, oh, but why does it do that? Because it's not an array, right? You can just say that. Or somebody might implement something else. But if you do see the advantage, you say, oh yeah, I can definitely do parts, the each, the whatever, the select, all the kind of stuff. Then you want to look at enumerable. Now, enumerable does not have all the methods that array has, but has a lot of them. And again, here in 3 simple lines, you get like 20, 30 methods that make your life way, way easier. I don't know if you notice right here, select uses each as well. So like there's not even here, there's not parts of the select, it just select. Made even that like slightly simpler. Now sending plus will still result in a no method error. But now it responds to size, each, and all the other stuff. It will raise this error when you treat it like an array. And again, it can be good enough. And it shows here the code, spares the size, parts the size. So I have more parts than object actually needs spares. All right. So the big downside of this is the creation right now of all of the parts. Because like everywhere you have code where you want to create a new mountain bike, you have a lot of boilerplate code. You have, what was it? Let's make the example, like a chain. Chain equal parts that new and everything the chain needs. Mountain tire equal parts that new and all that. So you have a lot of boilerplate just to create like 4 parts, then the parts solver, and then the bicycle that you want. All right, so it talks about, well, maybe it's time to implement a factory. Now, it shows like we can come up with a simple 2-dimensional array where while you're introducing a dependency on the cardinality of your arguments. The first one is the description. The second one is the value. And an optional third value where say it means it doesn't need a spare. Now you can actually have, like, again, 4 lines of code, all the configuration for a road bike. Another 4 lines, there's a lot less typing. And even by looking at it, it's very, very transparent what's happening. And this is kind of the name of the game. Is it transparent? Yes. Is it usable? Yes. Is it exemplary? Yes. Like before, you will have like these parts that are new all over the creation of everything. And if you were to change how parts were created, you have 1,000 different ways and places to do it.
Yes.
Now we're introducing a factory. For as long as you use always the factory to build it, you have only one place. All right. So now we are looking at this parts factory, where you pass this 2-dimensional array, right? It's going to look through each one of this thing and grab, first, second, and third parameter to a part object, right? And over here, it says, well, just to have, again, less dependency, we say that the part class, you can inject that one, so you can use this part factory for something else. So you inject the part and the parts class. So again, you're gonna go parts class then new. You collect. So you look through all the configuration, first array, and then use the part class, which is part. Called a new with the name, description, and whether it needs a spare. And if it doesn't find a value, it defaults to true. The fetch method works for both array and hashes. So if it doesn't find it, it's your secondary value, which is optional. It becomes the value that it returns, which is very helpful. So now this is something interesting. Does it talk right now? No, I'll talk in a second. All right. This is the thing that jumped right away. Am I? The fetch. Then now it's duplicate the code.
Right.
So you could do it here, or I mean, you have to do it here now, but you will remove it from the part class. You don't need a part class anymore. All right, so now it's very easy. You know, again, it's very terse. You can again, using this, you should always use the config to create new parts, and we can see it returns and works correctly. And again, like we talked about, like by using the factory now, it isolates creation, isolates changes for how creation happens, and this will always create the correct parts. It's a valid way. So even like in level of knowledge, like when you look at the code a year or two from now, everywhere you're gonna see factory that build blah blah blah. You have only one class to look at to figure out how a part is created. Now the next thing, it talks about the only slightly complicated thing is this, which is duplicated in the part, right? And if we remove this one, and this is args needs spare now, this has become very, very similar to an open struct. So she rewrites it as with two methods now. They're both public. One, to build from a config file of many parts, and one for a single part. So now you have two ways of creating stuff that are very isolated, and it returns an open struct. So now this open struct, as we talked about before, plays the role of the part.
Right.
So your diagram hasn't changed, but your code has changed. You don't have a part class anymore. You just have this open struct that plays the role of a part. And if you gotta get this extra method now, there's an extra utility in case you need to create, for whatever reason in the future, a single part and not a multitude of parts. And again, the new version now returns an array of OpenStruct. So she goes over the code again. We got the bicycle again, very, very clear what it does. We got these parts with enumerable and the parts factory. And we got a row config. I mean, everything is like almost self-explanatory at this point. And let me see if there's anything here needs comment. Do you have a question?
I do have a question. I didn't see how parts being enumerable, she didn't really show an example of saying, oh, this new object that's now a parts object, and have it called size on it. All I saw was things that looked like arrays, like spares, and the parts method, or the parts instance variable being called size, the method size. But I didn't see an object that was a parts object, so like that's all that I'm missing.
No, well, actually it did. Let me show up here. At some point she did parts dot size. Right?
Oh, okay. Yep, thank you.
This part, the size,
yep,
it delegated.
Yeah. That would make sense. Thank you.
All right.
Yeah, I was like, oh, I see that we went through all this trouble of making it enumerable, but I didn't see it responding to enumerable methods.
Well, the enumerable methods happens here in the select.
Yes.
The size was the delegator. And they each made the enumerable work a little better. Because for enumerable to work correctly, you need to have an each. You define your each. That's I believe it's the only requirement. Let's see.
So that's what it means when I see the instance variable as one of the symbols being sent to def delegators up here. It's saying that calling out that variable that responds to size.
So whenever you call you do like a parts object, the size, it actually delegates to parts. That parts object that each it delegates to parts, so it loops through the at parts.
Cool.
Instance variable.
Really cool.
Yeah, there are a few that are very this one for ordering stuff, sortable, that kind of stuff. They're very, very helpful. So pretty much it goes into a discussion what a composed object it really is. Because again, it showed that so a composed object is made up of parts in which it expects to interact by a well-defined interface. And composition described it as a relationship. And the composed object depends on the interface of the role. Now, something that it talks here about composition and aggregation, which I guess sometimes the two are used the same way, are used interchangeably, but strictly speaking, the composition expects the object that is composed of to not have a life outside of itself. While in aggregation, the object that is composed of or aggregate of have their own life. It makes an example of university, have departments and professor, right? It's aggregation of professors inside of the department, main department into university. And if the university closes, we don't kill all the professors, right? They have life outside of it. While when you have a meal and an appetizer, at the end of your meal, the appetizers are gone.
That's true.
Like,
That's good. Good examples.
yeah, she's smart like that.
She's very smart.
She's very smart. And if you meet her, she's actually pretty fine too. So now, frankly, you can use say the term composition to refer to both kind of relationship, and we more explicit only when you want it. But generally, like nobody's gonna say, "Oh no, sir, I beg to differ. That is an aggregation." All right. So deciding between inheritance and composition. Inheritance is a code arrangement technique. And mainly, the thing that happens is different between the two is with inheritance, when you acquire behavior through inheritance, you reuse almost all of the code of the classes. But like the subclass changes this to like one thing, right? You have a very, if it's done correctly, the subclass has one thing that changes. This enough. In French, there's a term, like in French, it specializes the class for something,
right,
a specific job. And what you get is automatic delegation. Now, and mainly because it's the same object, right?
Just tweaked.
Yeah, it's the same object tweaked. So like when you call another method, it calls on itself. So it doesn't have to look at any other objects. Now with composition, you lose that. But you get you gain structural independence between all the objects. Also, you gain transparency. When you have, generally you want to stick with just a two-level inheritance.
Yeah.
But sometimes you might be forced to have, a subclass of a subclass. When this starts happening, or even like with a single level subclass, sometimes because the methods are not in that class that you're actually calling them, making things, it's not really clear what this one extra method or this different method does. You kind of need to look at the master class to figure out what's happening. You cannot just look at a subclass and say, "Oh, I got this." No, so you lose transparency. With composition, you have the level of transparency, meaning that each object is very, very transparent, but you lose transparency of the whole. Meaning, if you have a lot of object there, again, coordinated, every single small object is very easy to tell what the job is at. But like when you look at the master object that has all this other one, then it's kind of hard to see the whole gestalt of the.
That's true.
All right, and actually, it's separate. You need to accept the consequence of inheritance and not going to choose one or the other. So benefit inheritance is reasonable, is usable, it's very easy to do. It's exemplary, meaning, once people see, oh yeah, this is how you do it, they can repeat it themselves. They can come up with new subclasses themselves. But the transparency, as we talked about, is reasonable because big changes can be done by a small amount of code. You can easily create new subclasses, and it provides guidance, right? And there are certain things that they have like the is a type of relationship It talks about the numeric class provided the sample of integer and floats. They are modeled as a class of numerics because they're both numbers. They both describe numbers. The cost of inheritance is very often you might choose inheritance to solve the wrong kind of problem. And most likely than not, your code will be used by others for purposes that you did not anticipate. And all those things like transparency, reasonable, usable, all those criteria have a flip side to it, right? So we talked about the flip side of reasonable is the very high cost of making changes near the top of an incorrectly, again, importantly here, incorrectly modeled hierarchy. But generally, even if it's modeled correctly, if you make changes to the top object, if all the changes propagates all the way down, and that causes side effect you might not expect. The positive side of usable is the possibility of adding behavior with new subclasses, and it brings up the recumbent mountain bike, right? You cannot mix those two things. Exemplary is like if this was the wrong solution and everybody copied it and put it everywhere, now you got a lot of places to fix, which is very, very hard. So let's see. But again, you know, you have to. It's kind of hard to figure out which one it is. It goes on a little bit about next, but you kind of have to always debate: is all this new code worth the effort? If I know maybe I'm the only user here, and I know that I'm not going to do this stack class might be good enough. Sometimes you have to go with it. Not enough.
Isn't that the agile way, though, the good enough?
Yeah.
You know?
Yeah.
And I think that works by being humble and not thinking that, oh, this is the best and everyone's going to use it. And it's like,
yeah. And we experience also sometimes like this has a relationship. They'll just jump at you,
okay. Yeah.
right?
Right.
So a lot of times I see stuff. I was like, oh, that's just like something else. Sometimes I don't see it, or I go, yeah, that seems like a little more work. I know you're not gonna do it. So composition, again, transparency. It's easy to understand the code. It's clear when it happens and when it changes. Everything was small, single responsibility. You made a change, changes only there. Is reasonable. Like in the case was like come up with variants require no code changes. There was no code change. It was even better than the other one. It was like before you had a small change and a small code change, big change in effects. Now it's like there's no change in code. It's just like it's a recipe. Boom, done. Each object, everything they participate, they're independent structurally, they have well-defined interfaces, and it's usable, of course. Now, the cost of it is what I talked about before, is like every individual part may be transparent, but the whole may not.
It's like anti-synergy. Where like the combination of things is just a big message. It's like, I can't understand what's going on.
Exactly. It's kind of understanding a full engine, you know, of a car. Yeah. I don't know all the parts. Also, you get like a structural independence, but at the cost of automatic message delegation. I can deal with that.
Yeah.
And generally, you always have there's always generally like a flip side to everything. So choosing relationship. So we looked at classical inheritance, behavior sharing by modules, which is roles behavior, and composition. And again, it talks about here, like it brings a couple of things, like inheritance is specialization, like specialized class. And over here, Eric Gamma, I guess all of them said this. Yeah, inheritance is best suited to adding functionality to existing class, where you use most of the old code and add relatively small amount of new code. In general, like when you add like a method to change a variable, that kind of stuff. And you use composition when the behavior is more than the sum of its parts. And this is like kind of makes sense, but it's like hard to really see. But you have to go back to what kind of relationship these objects have to each other. It's a is a type of relationship, has a, or behaves like. And I think those are the best criteria
for creating objects.
Now, if it is a, then it's you will use the inheritance. Behaves like, you use roles and modules. If it has a, composition, right? And sometimes it's hard. Like it behaves like and is a are very, very similar. But they sound similar, right? But again, if you start thinking, like if you have a model of what normally is used, like behaves like something, like sortable, behaves like something sortable, behaves like something numerable. Those are good examples. What are, let me see, what schedulable, preparable, printable, persistible. These are the examples that she makes. But if you just to look at the Ruby language and you say, well, those are good examples. Enumerable, sortable, forwardable. Like when you have something that can have a role and gain behavior that way, that's probably all you need. Use a module. If it's like, no, these are like, they're all the same type of objects, right? Like a numeric float. Yeah, integer. Boom. Or if it has a type of distinction, then you'll go for composition. Yeah, 4 minutes left. I didn't hear any comments. I was talking a little fast. Let me see if I can stop the screen share. No, I can't. There you go. Yeah, stop? Yes, stopped.
Oh, cool. That was good. I kind of do agree at the end with the. I think it goes pretty far with an is a versus a has a description. Right, a bike has parts. It's not kind of parts.
Right.
A mountain bike is a kind of bike, and perhaps there's some behavior to be shared or changed, which goes back to our specialization thing. At the moment, there is none, so there's no real need for a mountain bike subclass, which could change depending. A lot of times, I think of inheritance as far as is really behavior, which she says acts like.
Yeah, but for example, for me, it would be like a mountain bike is still a bike. It's just like nothing about it is different than any other bike, really. But a motorbike, it is a kind of bike, but it's very different.
Yeah.
Right? Or an electric bike. Yeah, it's the same parts and everything, blah, blah, blah. But now you have specialized something. So I think like a
I like the electric bike example because now it's like everything plus that might require a new object,
right?
The motor.
Like you could do this like with the scooters or what the
moped.
No, like skateboards. You know, those that they have like a little
electric
Playmobil,
like a remote.
button, like a remote accelerator.
Yeah.
And those are like there's just mods to a skateboard. So like if you were to model that, you would have a normal skateboard, and then you have electric skateboard.
But if you flip that mod can be applied to scooters. So now you can start like, and everything else is kind of arbitrary.
Oh yeah, now you might have.
It's like that the interface, the motor, the charging, all that mod, and you can apply it to it. You could like apply it to these chairs. And
motorized chair, yes.
Yeah, zooming across the room.
Let's see.
What is
so ultimately, I think of like inheritance is usually because you want shared behavior. You want to reuse behavior,
right?
Which you can do through inheritance or composition, depending on, again, structure, whether you're made of or you're another kind of, right? So I think that's pretty good. I think you get there 80% if you try to model the real world. There are some edge cases that doesn't work. And of course, in Ruby, because we have modules, we can actually not inherit and share behavior, which is useful. And again, we get all the benefits they say about automatic delegation. If you,
by the way, I think it's like the example that she makes it with the bicycle is very, very obvious because it is a real world object that everybody's familiar with.
Yeah.
But although you do have to think about it a little bit. But when most of the time when you're coding stuff, a lot of these objects are like made up objects. So like I think that's when the challenge comes because these are not nothing that have to do with numbers or something that we can relate to outside of the domain knowledge of the problem that we're trying to solve. And I think generally, unless you start knowing the business rules and everything perfectly well, you're going to end up getting it wrong most of the time. Because, like, you're not going to understand it whether this is or has a type of relationship with a concept that you're not very, very familiar with.
Yeah. Yeah, you'll change. Things will change.
Yeah, and again, things
and legitimately, it's right, and then you end up with something else as things change or you understand more, or you get more requirements. Yeah, no, I thought that was good. Any other comments? Don, Sam, Scott? So the only thing I felt I didn't quite agree with was backing down to OpenStruct. Because invariably, part will probably have some behavior later.
Yeah.
And OpenStruct only saves you a couple lines from her basic. I mean, it was just a shell class before. But I just figure eventually part will have its own behavior. So I think in general, I don't like the idea of objects that are just data structures.
I think if personally, if I can get away with, I'm good. But like half of the time, I end up extracting it. And again, it's just like part of it is the idea of the smallest amount of design. Like right now, you don't need to know. Like when you look at the code, it's extremely reasonable, right? You don't have to look at another class and try to figure out what other behavior this part contains, you know it's just a shell. It's a
Right.
it's a
Until you need behavior, then you need it.
right. But if you start having like some other things, or you want to add, some niceties, like need spare question mark. Yeah, you want to.
I think it's the longevity. If your code is going to live for a while,
Mm-hmm.
I'd say most of your data classes end up having functionality with them. If it's a script to fix something in a half hour,
Yeah.
It may not likely change. I think the likely, and this is everyone's personal experience. I think for me, all my structs end up having behavior. So, and the shell is not that bad. Class, parts, adder, accessor, a couple lines. It's like, oh, only save a couple of lines.
True.
Okay, cool. If there's no other comments, we just need to pick who does it next time. Chapter 9.
I think it will always be Andrew.
Sam, he hasn't gone yet.
Or Brad.
Don hasn't gone yet, right?
Donna. No, Donna's. Donna's and Donna? No, Donna's Donna.
Yeah.
Sam. Oh, Brett hasn't gone?
Brett's gone.
Yeah, he did it. I think we went with me because we want to loop around.
Yeah. Plus, we didn't have Sam last time. So Sam is a possibility. If he can make it, we won't force it. If not,
I'm going to pick somebody.
oh,
Unfortunately, I don't think I'm gonna have time this week. Thank you, though. Sorry.
you got 2 weeks actually, but
Oh, all right. I'm gonna pick Andrew for designing cost-effective tests, which he loves.
That's right. That's true.
Like that chapter was specifically written for Andrew or Scott.
Excellent.
okay. Let's see. So what is chapter 10?
And with that, we end the book.
Yeah, it's a long chapter.
That it? That's the last chapter?
Oh my gosh. All right, get ready.
All right. Well, then, if it's the last chapter, I think we will not cover the whole thing because that's true. Is that not true? Is that long?
It's really long. Really long.
I got to get the website up.
It's about 50 pages. Mine was 30.
Yeah. All right. So
A little longer. It's going to take two sessions.
Yeah, probably.
2 sessions is good. All right. Well, then, thank you. Welcome. Hope you enjoyed your time, and we'll see you in 2 weeks.
All right.
Bye.
Goodbye.